Hey, Mr. Kaczynski with you. I'm going to take you through 4.5 practice your skills, namely point slope form today. Here we go. Name the slope and 1 point on the line that each point slope equation represents. Okay, slope. Let's start there. So the slope would be these numbers that are being multiplied in front of the parentheses. All right, yeah, so all of these. We'll just say the slope is 4, 2, negative 3.47, negative 1.38, 12.3, and negative 2.4. Okay. And now we're going to go with the a point that this runs through. Okay. So it's actually the opposite of this and then this. So in this case, the point that this runs through is 5, 3. 5, 3. Let's check that on the calculator, make sure that's working. 3 plus 4 times x minus 5. Trace it and type in 5, enter, and you can see that runs through 5, 3. Okay, so it runs through an infinite number of points, but that's going to be the one I'm going to choose. So this one runs through the opposite of that, which would be negative 3.1, 1.9. So we want the opposite of this because we're subtracting it, and then this exactly because really, maybe this one would do a good job of showing it, so I'll hold off on saying that. So 7, negative 2. This one is 2.5, the opposite of negative 2.5, and 5. This one is negative 4, negative 7. And this one, see, now that's y minus negative 8. So in this case, it is going to be the opposite of this and the opposite of this. Because it's really subtraction all the time. It's really always opposites. But on this one, the negative 5 has been added to both sides and became a positive 5. So this one would be 3 and 8. Because another way to write this equation would be y equals negative 2.4 times x minus 3 plus 8. So there's that positive 8. All right, now we're going to write our own equations in point slope form of a line given its slope and 1 point that it passes through. So here we go. Let's go y equals our slope, which is 3, times x. We're going to do the opposite of this value right here. And then we're going to do plus 5. And that is point slope form. Okay, again, y equals negative 5 times x minus 1 minus the 4. Y, let's go a little smaller here. Let's go y equals negative 1 times x minus 3 plus 0. There's a couple things I don't need. That 1 right there and that plus 0. So let's simplify this and make it negative x minus 3. We'll call that our final answer. Y equals 4.4. Instead of x minus negative 2, although that would be true, look at what a mess that looks like. Let's fix that. Instead of x minus negative 2, let's just call it x plus 2 plus 3. Y equals 0 times x minus 3 plus 7. But isn't 0 times anything just 0? And isn't 0 plus 7 just 7? So, the point slope form of this equation, when I simplify everything, I'm just going to call it y equals 7. this one, y equals, I could put 1 times x plus 3.1, but I think I'm going to get rid of the 1. I don't need it, right? Let's just do 1 times x minus negative 3.1 or plus 3.1. Excuse me. Minus the 2.8. So the 1 is there, but we just don't need to write it. A line passes through these 2 points. Find the slope of that line. Okay, let's do change in y. So 13 minus negative 1, or 13 plus 1, same thing. And then we'll do 5 minus negative 2, or 5 plus 2. So that gives us 14 over 7. The slope here is 2. Write an equation in point-slope form using that slope that we just found and the point, this point. So that's the first point, okay? So we're going to write y equals 2 times x plus 2, because remember we're taking the opposite of that negative 2, and then minus 1. And then this says write an equation in point-slope form using the slope we found 2 and this point. So that's the second point. Okay, it's going to be slightly different. Y equals 2 times x minus 5, because I always want to take opposite of that x value, plus 13. Verify that the equations in 3b and 3c represent the same line. Enter the equations into your calculator, compare their graphs and tables. Here we go. Let's go to y equals, clear that one off. The first one was 2 times x plus 2 minus 1. The second one is 2 times x minus 5 plus 13. Let's graph those. There's the first line. And I don't see a second line. Why don't I see a second line? Because they're actually the same line. So if I go second graph, I can see for all these different inputs, both equations give the same outputs. So that really is the same line. If I hit trace, you can see I'm tracing the first line. And then if I hit up, you can see I'm tracing the second line, but nothing, it didn't move. Okay, so tracing the first line and tracing the second line are the same. Number 4, write an equation in point-slope form of a line passing through both points. Check your equation by graphing it on your calculator and verifying that it includes the 2 points. All right, so we always have to find slope. So let's do change in y over change in x. That's 6 over negative 3. So our slope is negative 2. So we could do 2 equations here. First equation could be y equals negative 2 times x minus 3 plus 0, but I'm not going to put the plus 0. So that would be using this point. And the second one using this point could be y equals negative 2 times x minus 0. Do I really need to put x minus 0? How about we just put x plus 6. So that one ends up looking like slope-intercept form. Let's graph them both. Negative 2 times x minus 3. And negative 2 times x plus 6. Let's look at the tables. That's the easiest way to tell. Yep, same values, so I must have did it right. All right, 5 minus 3 over 5 minus 1. That's going to be my slope, which is 2 over 4, or 1/2. So first equation, y equals 1/2 times x minus 1 plus 3. Second equation, y equals 1/2 times x minus 5 plus 5. I'm not following directions entirely. Actually, we don't need both of these equations. You only need one of them. And then we just got to verify that it goes through those 2 points. So going back to A real quick, I can see it does go through 3, 0. There's 3, 0. And it does go through 0, 6. So let's pick one of these. I'm going to do both of them. I mean, it just makes sense to check it. So 1/2 or 0.5 times x minus 1 plus 3. And then we got the 1/2 or 0.5 times x minus 5 plus 5. Second table, they're the same. They go through 1, 3, and they both go through 5, 5. All right, slope 4 minus 1, that's my change in y. 2 minus -3, or 2 plus 3, gives me 3/5. So one equation I could write is y equals 3/5 times x plus 3 plus 1. Or if you want to use the second point, which it really doesn't matter, you could have y equals 3/5 times x plus 3, x minus 2 plus 4. All right, so 3/5 times x plus 3 plus 1, and 3/5 times x minus 2 plus 4. Second graph, same tables, -3, 1, yep, they both go through that, and 2, 4. Yep, they both go through that. One more here, on number 4 anyway. All right, 4.9 minus -3.1, or just plus 3.1, and 6.5 minus 2.5. That doesn't turn out to be as bad as I thought it was going to be. That's just 8 over 4, which is 2. So you could write this equation, y equals 2 times x minus 2.5 minus 3.1. Or you could write the second equation, y equals 2 times x minus 6.5 plus 4.9. To save time, I won't bother graphing them or looking at their tables. Lauren rode her bicycle home from school. This equation gives her distance d in miles after time spent riding t in minutes. Caitlin also rode her bike home from school. The table shows her different distance from home at various times. Okay, so which girl is riding at a faster speed? Well, let's see. Lauren, she's going 0.15 of a mile per minute on her way home. Caitlin, let's see, -0.6 over the span of 5 minutes. So this is 0.15 of a mile per minute. If I do -0.6 divided by 5, it's -0.12. So which one's going faster? Lauren, okay? So Lauren is going faster, 0.15 miles per minute compared to 0.12 miles per minute. And which girl will reach home the soonest? Well, there's a couple ways we could do this. We could, well, let's look at Lauren. When's she going to reach home? Let's use an equation. So when will her distance be 0? So we can solve this. We could subtract 3.6 from both sides. And then we could divide both sides by negative 0.15. And then we could add 20 to both sides, and we can see that Lauren will be home in 44 minutes. And then we could do a recursive rule for this one. Maybe we go, well, we know that she's losing. Well, how about we just go every 5 minutes? So we could go like 3 minus 0.6, and that would be after 30 minutes. And then 35 minutes. Oops. I have to subtract the 0.6. So there's 35 minutes, and there's 40 minutes, and there's 45 minutes, and she's still not home. And it's going to be 50 minutes before she gets home to 0 miles from home. So, so Lauren is actually going to get home first, right? 44 minutes compared to 50 minutes. All right, that's all I got for you. Hope that helped, and I'll see you soon.